Right, welcome, ladies and gentlemen. Let's go ahead and let's begin. We are going to the next level of exponents. So those of you who are with me Monday, we have like a little ed puzzle, really easy. Hopefully remember it from before spring break. And then today we're going to do the next thing, okay? So if you notice, I'm going to go ahead and pull this up. Let me see. Pull this up really quick. Right here. Let me go to, just so y'all know where it is, okay? So you go like, right now I'm recording this in 8th period, so I'm gonna go to 8th period. You go all the way down, and you'll notice there's a star reference sheet. Just pop that out. And ladies and gentlemen, we have this. So now in the past, you will have access to this sheet on your exam. In the past, before spring break, we talked about product of powers and we talked about power of powers. And today we're going to be talking about quotient of powers, and we're even going to get a little bit into negative exponents. Okay, so we're going to be covering these two today. Okay, so let's go in there. And it'll be handy to reference that. Our objective, we will learn how to divide monomials with exponents. Okay, so before we get into the vocabulary, I want to take a little time. You can kind of create a little white space, or if you're using my notes here, we'll just do it right here. I want to make a little table, and I just kind of want to get your thoughts on this, okay? So here's my table. I've got, let's just, threes are easy, right? I'm going to say 3 to the power of 2, right? And then 3 to the power of 3, and that's 3 to the power of 1, and so on, right? So in the chat, or you can just blurt it out, what is 3 to the power of 2? Making a little table right here. So y'all answered 9, which is essentially the same as 3 times 3, right? And so in order to get 3 to the third power, that would be 27. That's just 3 times 3 times 3. Now, today, if I want to go backwards, okay, if I want to take it backwards, then essentially I am dividing by 3, right? That's 27 divided by 3 gives me 9, right? And if I divide this by 3, 9 divided by 3, I get 3, right? Which is just equal to 3 times. So now in the chat, I want you to tell me, what is 3 to the power of 0? What are your thoughts? So if we put in our calculator, 3 divided by 3 is actually 1. So good job, Miss Sophia. You are the happy winner of that one, divided by 3. 3 divided by 3 is just 1, okay? So right here, this is our rule that we're going to talk about. Anything to the power of 0 is always going to be 1 because we're just dividing it by the base, right? Now, as we get into negatives, if I continue to divide by 3, what do you think 3 to the power of negative 1 is in the form of a fraction? Y'all can put it in. And if you think you know this one, you can do that too. What is 1 divided by 3? So far, the closest answer I've gotten is 0.3. What would that be in the form of a fraction? There you go. You take this 1, right? And you divide it by 3. That's 1 over 3, right? And if I were to divide that by 3 again, alpha y equals 1, 1 over 3, and you divide that by, there you go. Good job, sir. Divide that by 3, you get 1 over 9, right? And do you see the relationship between this one and let's say like this? 3 to the second power is equal to 9. 3 to the power of negative 2 is 1 over 9. And so those are some concepts to kind of keep in mind today as we are exploring those two topics. Okay, guys? All right. So let's go ahead and let's go back to our vocabulary. Okay. So when we talk about zero exponents, we're talking about for any non-zero number A, call it A, where A is to the power of 0 is equal 1. This is just a really fancy way of saying anything to the power of 0 is 1. 2 to the power of 0, 1. 2x to the power of 0, still 1. Let's give you something really delicious here. Let's say negative 3x to the second over y to the fifth. Take all of that, put it to the power of 0, and it is 1. Is it always going to be over 1 over something? Oh, when we're talking about the negatives in the table, so the question was, is it always going to be 1 over something? Yes, if it is all by itself. And we'll get into some more complex examples of using the negative exponent. Okay. All right. So right here, anything to the power of 0 is 1. And my counter example, I guess I could say it again. Any non-zero number. By the way, I do my z's with a little line through it, so you know it's not a 2. So in case you're wondering what that is. Any non-zero number raised to the 0 power is equal to 1. Okay, so my counter example would be something like this. 2x to the power of 0. Put in the chat what you think that is. What is that going to be equal to? Remember, it is my counter example. All right, here's your hint. It's not 1, okay? It's actually this, only this part right here is 1, right? And so what you end up with is 2 times 1, right? And that ends up being 2. So don't think the difference between this and this is that you have the parenthesis, right? As long as everything is to the power of 2, then it is 1, okay? Does that make sense? So in this sense, right here, you had x to the power of 0. Only x to the power of 0 was equal to 1. So you had 2 times the 1, and you got 2, okay? Now let's talk about the formal definition for a negative exponent. A negative exponent is for any real number where a is not equal to 0 and any integer n, you have this situation. If you have a to the power of negative n, basically, you just take it from being in the numerator, put it down in the denominator. And so, yeah, that 1 is kind of a placeholder, sir. And you have a to the power of n. So we make it positive, okay? And you can kind of look at the table that we were looking at as an example. Or let's say that we start off and you have a negative exponent in the denominator. And we want to make it positive, so we bring it from the bottom and bring it up to the top. We make it positive, okay? So again, if you looked at our table, remember we had something that looked like this. We had 3 to the power of negative 2, and that ended up being 1 over, basically 3 to the power of 2, 1 over 9, right? If we had started off with, let's say that we had 5, I'm going to put it in a fraction, 1 over 5 to the power of negative 3. then this is going to be equivalent to, we bring it from the denominator up, and we make that exponent positive. Okay. Any questions? Okay. Let's see what else. My counter example for that one would be something that's not negative. I mean, just because let's say you have negative x to the 5th, that does not make it equal to, like, you can't do it like this. Okay. It's got to be a negative that's in the exponent. Okay. So that's my counter example. And order of magnitude, I'll go ahead and write it down, but here we go. Just so you know, you'll have it officially if you need it. The order, that's an H, sorry about that. The order of magnitude of a quantity is the number rounded to the nearest power of 10. Okay. All right. So let's go ahead and let's get into some of this. I hope you find that it's relatively simple. Okay. So example number 1. We want to simplify this and assume that x and y are not equal to 0. So before I start this, just real quick in the chat, tell me, what is 5 divided by 5? What is 2 divided by 2? Good. And x divided by x? Yay, yay, yay. It is 1 every single time, right? When you divide something by itself, you get 1. Excellent job. So what we're going to do is we're going to go ahead and we're going to do this the long way, okay? And then we're going to kind of look at the rule that will make our life a lot easier. So I'm going to take this x to the 7th power. I'm going to write x to the, like, 7 times. Okay. And
Ms. Dominguez,
yes, ma'am.
can you scroll up a little bit, please?
Sure. Is this enough?
Yes, thank you.
Okay, cool. And then I have this. I'm going to do it 6 times on the bottom, right? I'm going to go ahead and do the y's. 12 times. I better write small. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1, 2, and 3. Okay, and on the bottom, only 3 times. Thank goodness. All right, there we are. So now we said that if you divide something by itself, it cancels out, becomes 1, right? I like pink. So here, that's just a big 1, right? 1, 1, 1, 1, and 1. So we get 1x. Right? Here I have the y's. 1, 1, 1. 1 times 1 times 1 is just 1. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 1y to the 9th power, right? And so really I mean, that's times 1y to the 9th power. Really don't need the ones, right? That could just be written as xy to the 9th power. Yeah, I really feel like erasing that and making it nicer. So can anybody tell me the smarter way to do this? Instead of how can I go direct from here to there? Any ideas? Yeah. There you go. So man, you're like on it. Okay, so let's go ahead and let's look at our little handy dandy sheet, which we will have access to on the star. And we're going to be focused on this whole quotient of powers. And like one of the big hints is like, you see this big fraction there? Well, this one actually has a big fraction. And what do we do with our exponents? We subtract them. So long as the bases are the same, we subtract our exponents. So that's exactly what we're going to do. If I wanted to do it the easier way, I probably could have just said x to the power of 7 minus 6, right? And then I could have done y to the power of 12 and then subtract the 1 on the bottom, minus 3. And so that gives me 1. 7 minus 6 is 1. And then y to the power of 12 minus 3, that's 9. And of course, you can see that it still would result in this. Any questions? So yay. And if you forget, what do? You can always look at the sheet and it tells you like, hey, all I had to do was subtract my exponents, right? Okay. So let's look at this right here. Let's see, I'm going to scoot this. Somebody's going to be like, I'm still writing. Okay. But I'm curious, what property, let's see if I can kind of squeeze it so you can all see it. What property am I going to have to use first in order to simplify this? What do y'all think? And I'm going to make this just a little bit bigger so it looks like. Okay. What property do you think you're going to use first? Product of powers, quotient of powers, power of a power, or negative exponent? Thoughts?
The first one.
The first one, the product of powers, okay? The power of power. Okay, so we're kind of between two. Product of powers and power of power. So what's unique about the power of power is that you have the big parentheses, right? That's a good indication. Here you have all the bases the same, but no parentheses, right? So the fact that we have those parentheses tells me, you know what, we're probably going to use power of a power. So you've got this exponent right up against there, yes? So let's go ahead. And what we're going to do is apply power of a power, which means that we just multiply. See, that's m times n. I'm going to put in any of my ninjas. Really important that you include those ninjas. And the only thing that's different with a fraction is that you are actually going to apply the and multiply the exponent of 3 times everything in the numerator and in the denominator. Okay? So that's one thing that's really, really important. So I'm going to go here and I'm going to write in 4 to the power of 1 times 3 and c to the power of 3 times 3, d to the power of 2 times 3 over 5 to the power of 1 times 3. Then I'm going to go ahead and clean it up with just a hair. And I've got 3 times 3, that's 9. And then d to the power of 2 times 3, oops, that's 6. Okay. And then on the bottom, I have 5 to the power of 3. Okay. Now, if the bases were the same, yes, you could do some stuff with this. But honestly, what I'm going to recommend is anytime you have these coefficients up front, they're just normal numbers. They're, they multiply, subtract, divide the same way they did when they were in 3rd grade. And so all you can do, you can even put them in the calculator. Right? You got your 4 to the power of 3 down, and you got 5 to the power of 3, and then over, and then there you go. Okay, not pretty, but that's as easy as it gets. 125, c to the 9, and d to the 6. Okay. So just a couple of rules for simplifying. You want to make sure that your coefficient is simplified. You also want to make sure that you don't have any repeating bases, right? And also no negative exponents, okay? So I'm going to say coefficients must be simplified. Oops. And then I'm going to put in here no repeating bases. And I think this was actually outlined in another document. That's okay. So no repeating bases. And then finally, no negatives, no negative exponents. No negative exponents. Those are basically the three things. I think that should get you pretty far. Any questions? Feel okay? All right. So let's go ahead and let's move on to example 3. And we are going to simplify this. Who can go ahead and put the answer in the chat? What is the answer to this ugly looking problem? Give you about 5 seconds because you should be able to look at it and go, oh yeah, I remember my definitions. Oh, look at your definition. That's why, guys. Y'all got to write it down if you're going to do this at a high school level. Okay, ladies and gentlemen, anything to the power of 0. What's magical is that 0. And notice how it's all, like, that's not very good, but it's all entirely, right? So yay, yes, it is 1. Ta-da! Right? Because everything is to the power of 0.
Wait, why is it not 0 again?
Okay. Well, when we went to our table, hold on, let me finish my thought here. Because everything is to the power of 0. You can always test it out. If you forget the rule, you can always say like 3 to the power of 0. I'll tell you 1, okay? But the reason when we were kind of doing that table, let's see if I can find it. There's the table. See how like when we move backwards, we're like dividing by 3, right? So essentially, anything to the power of 0 is 1 because you are dividing by the base itself. Anything divided by its base, anything divided by itself is 1, right? And so that's why anything to the power of 0 is 1. Question? Because when we divide by. And that would work for any number. If I did a table with 5s, that would work if we were dividing. Okay. Good question. All right, let's look at example 3b. So we want to simplify this one and assume that m and n are not equal to 0. How do you know which equation we would use? Oh, like, okay, so I'm answering a question right now. And so are you talking about like which property I would use?
Yes, ma'am.
Okay, so one of the things, number one, you know, something to the power of 0. I wonder if that's even on here. If that's just something that they expect that you memorize. I think that's something they expect that you memorize. But for example, product of powers, what stands out to me on this one right here is when you have bases that are same. So like, let's say you have 3 to the power of 2 times 3 to the power of, I don't know, 4. So notice how the bases are the same and each exponent has its own base. And so this right here would be 3 to the power of 2 plus 4. Okay, that would be an example of that one. The major thing that stands out for me on this one is the fraction. If you are, you know, using a fraction, okay, quotient means to divide. Well, that's what the fraction sign means, right? So that's a good indication you're going to use the quotient rule, right? What stands out to me with power of a power is parenthesis. And remember, when we've been studying, we always think, oh, parenthesis, I need to multiply, right? Same thing here. Look, you're multiplying m times n, right? And then with the negative exponent, we're going to talk about that in a little bit right here, okay? And let me know if you still want more explanation on that once we do. Does that kind of help clarify that?
Yes, ma'am. Thank you.
All right, cool. That's a good question because that's actually the tricky part. Is that when we get into it and it's like all mixed up together, that's the crazy part. Okay. So let me go ahead here and we're going to talk about this one. I'm going to actually give you a 30-second head start on this one. Okay. Go ahead and put your answer in. I'm going to pause. Okay. So my favorite answer was actually just n. Let me show you how you do this. So m to the power of 0, like we said, anything to the power of 0 is just 1, right? So I'm going to go ahead and plug that in. That's 1 times n to the 3rd power over n to the 2nd power, right? Okay. Which basically simplifies to become this. Now I can look at my little sheet. Maybe I drag that over here, drag this over here somehow, right? And I've got the fraction, so I'm going to look at the quotient of powers and I'm subtracting, right? So that's going to end up being n to the power of 3 minus 2. Well, that's just equal to 1. And technically, that's just like a ninja, so n is my favorite answer. Questions? So I noticed a lot of people didn't remember this part right here. And so I would definitely make a note of this. Anything to the power of 0 automatically becomes 1. Replace it with a 1. Not the exponent, but the whole shebang. Yes? Okay. Let's go ahead and let's look at this right here. We're going to talk about negatives. Now, with negatives, I want you to kind of think of when something's negative, they are unhappy, right? And we want to make them happy and make them positive. Okay, so here's the idea, is that I have this, my x is negative, he's not happy. So he lives upstairs, okay? I guess he doesn't like it upstairs. So we're gonna move him downstairs. And we change his exponent to be positive. So now he is happy, he is positive, yes? I've got y to the 9th. Is he happy? Yes, let him live where he wants to live. There he is, okay? And then z to the negative 6th power. Unhappy, right? So we're gonna move them upstairs, z, and make the exponent positive. And I'm gonna rewrite it a little nicer and make sure that it is in alpha order.
Wait, it's not gonna go on the bottom one?
The z,
Yes.
no, because remember he was unhappy, and so we move him upstairs.
Oh, okay, makes sense.
Okay. If this one is unhappy, we move him downstairs. It kind of starts like, where do they originate? If they originated on the top, you move them to the bottom. If they originate on the bottom, you move them to the top. And of course, if they're happy, leave them alone. And there you are. No repeating bases, no coefficients that need to be simplified. We're good. No negative exponents. Check, check, check. Questions?
So that would be your answer.
That's the actual answer. Yeah. Okay. Go ahead and do example 4B. I'm going to pause the video. All right. So here's what we're going to do. First, we just deal with the numbers, right? You've got 75 divided by 15. Numbers are normal. So you can just put them in the calculator. Got like way too much stuff up here. Hold on 1 second. There we go. Okay, I'm going to go ahead and put it over here. And alpha y equals 175 over 15. I get 5. Great. And it's up on top. It's not 1/5, it's 5, so it's on the top. Okay. Then I have p to the 3rd power minus 5. Does everybody know why we're subtracting? Okay, because we're using the quotient rule, remember? Okay, so when you have the big fraction, you subtract. Then I got m to the power of negative 5, and I'm going to subtract negative 4. Keep all those negatives straight, okay? And then r, nobody wants to play with r, so we're just going to leave them on the bottom, negative 8, okay? There's nothing on top to like move them with. So let's go ahead. We have 3 minus 5. And that's negative 2. This ends up being a positive, and you know, if you want to do it, you could just say like negative 5 minus negative 4, and you end up with negative 1 over r to negative 8. Well, basically, none of my variables are happy. It's kind of sad, but we can move them, right? So I'm going to put 5. 5 is okay on the top. P likes to be on the bottom. Positive 2. M is also unhappy since he's negative, so we're going to move him to the bottom. Positive 1. Don't really need the 1 there. And I got r to the negative 8, so I'm going to move him upstairs so he'll be happy. And I'm going to rewrite it. I'm going to make sure everything's kind of in alpha order. And 5r to the 8th power. And I really don't need that ninja exponent. And element OP, yep, they're in alpha order. And P to the second power. And ladies and gentlemen, this is your simplified answer. No negative exponents. All your coefficients are simplified and reduced. And you don't have any repeating bases. Does anybody have a question on that?
So when you're using, like doing the letters and stuff, you would put them in alphabetical order.
Now, are you going to take like a quiz, or, you know, in your life you'll work, you know, you'll see a problem and it's not in alpha order? Yeah, but that's just kind of in general, you will tend to see it in alphabetical order. Yeah.
Okay, thank you.
Yeah, no problem. And in my problems that I put up, if I think I stayed in there, like I want it in alpha order. So yeah, just go ahead and do that. Any questions on that? Okay. And one little thing that I think might be a hint, just saying, if you had a problem that looked like this, let's say you had something like, let me draw a little box. Oop. Maybe I should like put it on the bottom here. Yeah, I'll put it on the bottom. Let's say you had something like this, x to the power of, I don't know, let's say 5 over 2, okay? And you have it like this, -1. You know how we talked about that you could definitely, you know, apply the -1 times everything, right? Boop, 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 boop. But I just want to kind of throw this at you. This is equivalent to 2 over x to the 5th. Does anybody need an explanation why?
I'll take-
Go ahead, sorry.
No, I do need an explanation.
Okay, so like, if I were to do this and distribute it to the 5 and to the 1, okay, I would end up with this. I would end up with x to the power of 5 times -1 over 2 to the power of 1 times -1. This ends up being x to the -5th, right? 2 to the -1st, right? This 2 is unhappy, so it moves upstairs, becomes 2 to the 1st right here. And this x to the -5th is unhappy, and he moves downstairs. So see how these two are the same thing? Boop. Same thing. And so if we kind of had known right from the get-go that -1 essentially just takes anything that's on the top, and it's like the reciprocal, right? Anything that's on the top goes on the bottom, anything on the bottom went to the top. That might help you with some of the things coming up. Any questions, guys? All right, y'all have a beautiful day and good luck on your assessment with this.